Good afternoon, Tashi.
Afternoon, sir.
Hello, good afternoon.
Yes, sir. Can you hear me?
Tashi, if you're speaking, I'm not hearing you.
Yes, sir. I'm hearing you. Can you hear me?
Oh,
Hello, hello.
yeah. What again, Tash?
Yes, can you hear me? Hello?
All right, hold on. I need to sort out the sound. All right, hold on.
Okay, sir.
Afternoon, sir.
Hey, Shamari, how you doing?
Pretty good, sir. And you?
Hold on. I'm trying to. Tomorrow, can I just see something? Okay, let me see something. That's fine. Shamari?
Call me, sir.
Yeah, all right. I'm not hearing this through the. All right, hold on. All right, okay, Tash. Um, mm. Shamari, can you say something I didn't know, please?
Sir, I am here speaking.
Right. Sorry, my process. I said, speak again, no, Shamari.
Healing wonders of water.
You're in a perfect fine. I'm using a headpiece. So I needed to join on that. All right. Were you able to check your run for for your grades? Mari? Mario?
I'll
Did
go
you
and check now, sir.
online? You might go check for me now, please.
Yeah, it's like 2 minutes ago.
Yeah,
It's too long.
you check.
Check again now?
You checked 2 minutes ago, it wasn't there?
Yes, sir. Check now?
All right, just double check again to see if the grades are uploaded for me, please.
All right.
In the meantime, we were looking at the trapezoidal rule. Um, we're looking at the trapezoidal rule the last time around. As those guys check on that. Let me see if I can. The trapezoidal. Did you check tomorrow? Are you seeing anything?
Good evening, sir.
Not seeing
All right,
anything on my
Brendan,
end, sir.
you're not seeing anything. All right, so the grades were submitted. They were submitted. I don't know what is the delay, so let us just go as it is just now. Somehow this thing does not want to load. Let me see what is happening. Okay, it's loading. Loading. Should be equivalent. You know what class you don't follow this time. Hold on a minute, please, guys. I'm just hold on a minute, please. All right, so all right, so I am getting comments because people are not sure of their status, but I'm not allowed to say communicate anything as it relates to grades. So you all are welcome here today. I am not supposed to, and as team lead, I want to follow the rules. If any of my team members do it, I will get at them. So stay here today. I will speak back to Mrs. Campbell as it relates to that, and by Monday we should be sorted out. All right. But
So, sir, question. By when we are going to store then?
well, the grades were submitted. I mean, I did have the stuff by, I mean, on Monday. Truth of the matter is wasn't I wasn't well. I wasn't well. And I you know, there were some things that I had to do in terms of looking at the, you know, giving pretty much the best options. I have an idea. I know what it is, but you know, it has to be rectified first. So I'll allow them to. But don't worry. I will speak to Mrs. Campbell come tomorrow. I don't want to talk to her now because maybe she's in an evening class. So I'll speak to her tomorrow, and by tomorrow for sure. No, let
Sorry,
me
can I
tell you,
check the chat,
it's
please?
I have been, and I'm just laughing at Aston who tells me that is me pass on my sickness to her, but I didn't even see her after the exam. I saw my students in the exam, but didn't see them there afterwards. As them run out and leave. There's only one person come talk to me, but never mind. Yes, Mikey, I see your message, and I've seen Mario's message, and I've seen Tasha's message. No problem. I don't see any other message, and I've seen my AC message. But yes, you guys, trust me, I was sick the other day, and I came back down with the flu again. But I will be fine. Today's a good day. Yesterday was awful. Monday was awfuler. But anyhow, we did a quick exercise on Monday. Though we had some internet issues, but we did a little bit of stuff, and we were able to look at some of the trapezoidal stuff. We want to know, the topic is finished, we just really want now to apply the rules. And I want you to just refresh your memory on, and I don't know why it's not coming. Oh my goodness. When these things happen, you know, I feel like I'm unprepared, and I know that's not the case. I know it's not the case. All right, let me share this now. Yeah, I know it's not the case. All right, there you go. So we were looking at the trapezoidal, and the trapezoidal pretty much, if you want to ever remember what is happening just look at your hand. Again, I say to you, look at the palm of your hand. Put your palm of your hand in front of you. When you look at your hand, I'm going to ask that you put your your thumb close to your index finger. When you put your thumb close to your index finger, I want pretty much the spacing between fingers to be equal. The spacing between your fingers will be your trapezoids, and your fingers will be your ordinals. So how many trapezoids are you seeing on the palm of for one hand?
4, sir.
4. And how many ordinals are you seeing?
5, sir.
5, right. So always remember that you're going to have one more ordinal than you will have trapezoids. That is very important. And I'll tell you why when you start doing the calculations, that you see sometimes they mix up the question. Sometimes they'll say that 4 trapezoids, or sometimes they may say 5 ordinals. And the same to the question I asked. But because I hear 5, they use a different calculation, because that information is going to be very important for you to calculate the width of the trapezoid. So you need to know exactly what to do in order to calculate the width of the trapezoid. So all of that is going to be very important. All right. So having developed the rule, let us look at a question. Let us look at a question. And the question is, use the trapezoidal rule to estimate the integral of x squared minus 3 dx, where n is equals to 3. Where n is equals to 3. Now let me explain what is happening there. It says use the trapezoidal rule to estimate the integral x squared minus 3, where n is equals to 3. N is equals to 3. So what it is that we're doing is, we know n is the number of trapezoids. So it is telling us that it has 3 trapezoids. It's telling us that it has 3 trapezoids. 3 trapezoids. That's what it's telling us. It has 3 trapezoids. So look at my plus signs. I've written out the formula. Can I annotate? I've written out the formula. And I've written out the formula, and I want you to look at what the formula is saying. F of x plus 2, f of x1 plus 2, f of x2 plus f of 3. Remember I said to you that the first and the last one are going to be just one trapezoid that you're looking at. So you're not going to be multiplying by 2. Anybody remember that?
Yes, sir.
Yes, sir.
Good. So every other one is 2 trapezoids. So you're going to multiply those by 2. But the first and the last will be just one trapezoid. So if you go back to the palm of your hand and you look at how many of your fingers are touching the trapezoid, you'll be able to find out what number that is going to be associated with it. Always remember, the first ordinal is going to be touching just one trapezoid. The last one is also going to be touching one trapezoid. So whenever you're looking at your formulation, the first and the last will not be multiplied by 2. Every other trapezoid is going to be touching 2 ordinals. So you're going to be multiplying those by 2. Get that?
Yes, sir.
All right. Is there anybody that is not following what I'm saying? Talk to me. Hello, hello, hello.
Sir, can you go over?
So what I'm saying to you, okay, put back your hand in front of you. The palm of your hand is supposed to be facing. Use your thumb and just bring it in closer to the index finger so that the spacing between fingers are almost equal. Between fingers are your trapezoids, and your fingers are going to be called your ordinals. How many trapezoids are you seeing? Simon, was that you who asked me a question?
Yes, sir.
Yeah,
You
man.
said
So
outside trapezoids.
how many trapezoids are you seeing?
Sir. Sir, it's 3.
Really? You lose one of your
Sir.
fingers then?
Sir, 4. And
Okay, thank you, sir. All right, and how many ordinals?
3.
What? How many ordinals? All right.
There
So
is
I made
3?
an assumption. No, 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 no. I made
Oh.
I made an assumption. I made an assumption that all of us have 5 fingers. And don't tell me say your thumb is not a finger. In our Jamaican context, is a big finger. All right. So I made an assumption that we all have all fingers. Your thumb, your index, your middle, your ring, and your pinky winky. Is that a safe assumption that everybody has those fingers? We're not talking about the stubborn people them who have the other little finger at the bottom of the index, the pinky winky. So everybody has 4 fingers and a thumb, right? No?
Right.
Yes?
Right, sir.
Okay, good. All right. So that assumption is okay. What I'm saying to you, Simon, is if I'm just trying to give you a visual. If you put your hand in front of you, your thumb is brought closer to your index. Yeah, easy, Papa. Your thumb is closer to your index. The space in between fingers, including your thumb, is going to be called my trapezoids. It's going to be called my trapezoids. So how many spacing, Simon, are you seeing between fingers?
4.
4. And how many fingers do you have up?
5, sir.
5. So the spacings are known as my trapezoids, and my fingers are known as my ordinals. That concept is very important because of how the question can be worded. You follow me?
Yes.
All right. Are you getting a little better now? Just look at the screen. Look at the screen and see what is happening here. Let me go back up. All right. Look at my drawing. Remember, the three shaded ones are the 3 shaded ones. Okay, the 3 shaded ones are my trapezoids. All right. The space in between them are my fingers. Right. So my fingers would be at A, at X1, at X2, and at B. And the spacing that the spacings between the fingers, the ones that are shaded, will be my trapezoid. Can you appreciate that?
Yes, sir.
All right, good job. All right, so let us go to the question now. So we're supposed to be using the trapezoidal rule to find the integral of x squared minus 3 d of x. And it gave us a condition that n is equal to 3. What is n representing?
So the trapezoid.
The number of trapezoids, right? Very good. So n is representing the number of trapezoids. So this question is straightforward because it says n is representing the number of trapezoids. There are other questions that will give you information about ordinals, right? But the calculation won't have anything to do with ordinals. It will have all to do with trapezoids. So if you're given ordinals, you will have to convert those ordinals to trapezoids. Follow me?
So far, sir.
All right, good job. So our formulation must be written out. Remember, as I said to you, my first and last will not be multiplied by 2. Every other term is going to be multiplied by 2 because of the my ordinal touching pretty much 2 of the trapezoid. So put up your hand again, put up the palm of your hand again. Let us look at our index finger. Yeah, let us look at our index finger. If you look at our index finger, your index finger is going to be sharing the trapezoid between your thumb and index and middle. True or false? Talk to me.
True, sir.
Yeah, man. If you look at your middle finger, how many trapezoids your middle finger will be touching?
Two,
True.
sir.
How many trapezoids your ring finger will be touching?
Two, sir.
How many trapezoids your pinky ring will be touching?
One, sir.
One. And your thumb will be touching how many?
One, sir.
One. Right? So this is my formulation. So it has 3 trapezoids, right? Watch me, and I'm going to show you some tricks so that you'll never get these questions wrong. If you look at how many plus signs are you seeing in my formulation here?
3, sir.
3. So that gives you an indication. That gives you an indication as to the number of trapezoids. Right? So this trapezoid, so my plus sign will represent my trapezoid. So this trapezoid is going to be the first one, then the second one, and then the third one. So remember, we have one more ordinal than we have trapezoid. True or false? Talk to me.
True.
Come on. So I'm going to have 4. So this is it. So 1, 2, 3, 4. Now remember, my change in the value of x is going to be used to determine the width of the trapezoid. My change in the value of x is going to be used to determine the width of the trapezoid. Now to do that, it's going to be b minus a over the number of trapezoids. It's b minus a over the number of trapezoids. B minus a over the number of trapezoids. And remember, your b is going to be your upper limit, and your a is your lower limit. B is your upper limit, and A is your lower limit. Right? So the upper limit in this question is 2. So the formulation is always B minus A over the number of trapezoids. But your lower limit is a -1. So it's going to be 2 minus -1. Now, right here, when I have those 2 negative signs coming together, they are being multiplied. So when I multiply those 2 negative signs, it means that it becomes a positive. So I'm going to have 2 plus 1 is going to be 3. And 3 divided by 3 is going to be 1. So my width, the width of that trapezoid is going to be 1. Remember, I said to you, if I go back to the drawing, remember I said to you that they are equidistant. Anybody remember what equidistant means?
Sir, equal
Distance.
distance apart.
Equal distance, right? So they're supposed to be equal distance apart. Very good. So once I'm doing my stuff, my trapezoids must be equidistant. So they must be equal distance apart. If they are not equal distance apart, I cannot do it. All right. So it has to be equal distance apart. So I am calculating the width of my trapezoid. The width of my trapezoid is going to be 1. So therefore, my starting point is always at my lower limit. My starting point is always at my lower limit. So let's go. -1 is my lower limit. Remember, the width of the trapezoid is 1. So when I add 1 to -1, what do I get?
0, sir.
Excellent. So can you see the 0 right here?
Yes, sir.
Okay, when I add 1 to 0, what do I get?
1, sir.
Okay, can you see the 1 right here?
Yes, sir.
When I add 1 to 1, what do I get?
2, sir.
Good. So how many terms do I have here now?
4.
4. But the number of trapezoids equal?
3.
3. So you can understand now why the number of ordinals is 1 more than the number of trapezoids.
Yes, sir, I'm seeing it.
All right, always. Now remember, if the width of your trapezoid is incorrectly calculated, the whole question is wrong. So you have to spend some time at the start of the question to make sure that you calculate the width
Sir.
properly. Yes, please. Go
Sorry
ahead.
to cut you, but could you calculate the ordinals again for me? I was writing.
You are writing. All right. So what I'm saying to you is, in order for me to determine the width of the trapezoid, I will have to use the upper limit minus the lower limit divided by the number of trapezoids. It's always the upper limit minus the lower limit, and it's divided by the number of trapezoids. Now, the upper limit in this case is 2, and the lower limit is -1. So when I say 2 minus 1, those two negative numbers are being multiplied. So I'm going to have 2 plus 1, which is going to be 3. And 3 divided by 3 is going to be equals to 1. So what is going to happen is that the width of my trapezoid is going to be 1. Right? The width of the trapezoid is going to be 1. All right? So when I've calculated the width of the trapezoid to be 1, in order to space my trapezoids, in order to space my ordinals rather, equally, I will have to start with my lower limit. My lower limit is always my starting point. My lower limit is always my starting point. So I'm going to start with -1, my lower limit. So see the -1 here. And then I'm going to add my, my stuff to it, the width of the trapezoid to it. So when I add 1 to -1, what do I get?
0.
Shamari, when I add 0. And when I add 1 to 0, what do I get?
1,
And when I add 1 to 1, what do I get?
2.
2. Do I add 1 more to 2 to get 3? Let me see if you're thinking.
No, sir.
Do I add 1? Tell me why no.
We said that the
Because?
number of trapezoid is 3, and the number of trapezoids is usually 1 less than the ordinal.
Right, but there's something else, Aston, that you can use to tell me why I couldn't go up to 3. Look at the question and tell me why I could not go up to 3. You are correct, in that deduction. But tell me why I can't go up to 3. There's something else that will tell me I can't go up to 3. Look at it and tell me.
Because the trapezoid is equal to 3?
No, look at it again and tell me.
Sir, the outside of the ordinal.
No, that's what
I'm
Aston just said a while ago.
thinking that because the upper limit is 2.
And that's very correct.
Okay.
That's very correct. The upper limit is 2, so I cannot go to 3. Right? So if you look at the ordinals, can you see that the ordinals start with the lower limit and end with the upper limit?
Yes, sir.
Yeah, man. So you can't go up 1 more because the upper limit is 2. You can't go any higher. Make sense?
So
Talk to me
far,
now.
sir.
All right, good job. So now what we're going to be doing, I'm recalling what the so I'm recalling what the function is. Remember, we're not integrating, we're doing an approximation. So when you do the trapezoidal rule, we're not doing an actual integration. I know you know how to integrate, but we're not integrating. We're using an approximation method. All right. So what we're going to be doing now is for the function f of x, we're going to be substituting the ordinals into f of x. Right? So the question is even far easier than an integration question where you maybe have to use a substitution to get the answer. So I have 4 ordinals. So in my function, anywhere I see x, I'm substituting my ordinal. So look at me now. It is x squared minus 3. So I'm going to have -1 squared minus 3. -1 squared is +1. And +1 minus 3 is -2. Tell me that you agree with that. You agree with that?
Sir.
Yes, sir.
Yes, sir.
And then I move to the next ordinal, which is 0. 0 squared is 0 minus 3 is -3. And then when x is 1, which is a third ordinal, 1 squared is 1. 1 minus 3 is going to be -2. when x is 2, 2 squares is 4. 4 minus 3 is going to be equals to 1. Right? So these values are what I'm going to now substitute into my function. You see my equation right here that we wrote? That is going to be substituted into it. Give me half a second, please. All right, so that break is intentional. I want you to be able to look at it, what it is that we're doing so far. I'm taking a while to go through the question because I really want you to be able to appreciate it. Because after this, I'm going to give you one on your own to work for me. All right. So the first thing that we did, we recognized how many trapezoids we're talking about. We went as far as calculating the ordinals. We went as far as knowing what the width of the trapezoid is. And then what we did was to look at the function given, and then we substitute the ordinals into the function. So since there are 4 ordinals, we're going to do the calculation 4 times. And the 4 times that we do the calculation, we're going to be just going through with the calculation. 1 second again. All right, now, so when you look, when I did my substitution, I'm going to go back to my formulation. My formulation says the first one and the last one will not be multiplied by 2, but every other one will be multiplied by 2. So look at what is going to happen. My first one, which is going to be always be my lower limit, and my last one, which is always going to be my upper limit, will not be multiplied by 2. Every other one will be multiplied by 2. Watch me. This -2 is by itself. Lonesome -2 is by itself. Thank you. And then the second one is going to be -3. It's going to be 2 times -3 right here. The third one is going to be 2 times -2. And then the last one is a lonesome one. It's going to be just 1, not 2 times 1, just 1. So always remember, the first one, the last one are those two that will not be affected by those two. And you know why it's not going to be multiplied by 2. I don't need to go through that again. I spent the first class explaining why that is not going to happen. It will never happen, right? Because you're only touching one of the trapezoids. And all we do is just evaluate this. This 2 is this 2. -2, 3 times 2 is -6. 2 times -2 is 4, -4. And you take back down to 1. -6 minus 2 is -8. -8 minus 4 is -12. -12 plus 1 is -11. And I'm going to have -11 half. And that would be my estimation for my integral. Now, if you recognize, after I have calculated my ordinals, talk truth. Don't everything else here is easy 1, 2. Mere substitution, mere substituting and evaluate the stuff. Tell me, are those things pretty easy from there?
Yes, sir.
Yes, sir.
Yeah, man. So that is not where the difficulty lies. The difficulty lies at the start of the question. And that's why I spent so much time on that, because I really want you to get it. It's not difficult. Now, like I did for calculus 1, for those of you, I think all of you here, I would have taught calculus 1 too. Yeah. Like I did for calculus 1, I'm going to do for calculus 2. Now, calculus 2 is going to be a little bit more than calculus 1. Calculus 2 is going to take you into grown-up stuff. Calculus 1 was just the introductory stuff to the grown-up stuff. Now this is where the time meets the road. Big people stuff. All right? Not to get you afraid, but just to prepare you for what is to come. I don't want to tell you that it's going to be easy, and then it's okay, it's going to be easy, and then I can miss class. It is going to be rough, but is it doable? The truth is, the honest truth is, I don't even know if I should tell you, but the honest truth is, I prefer calculus 2 than calculus 1. Calculus 1 is just a whole lot of stuff. Calculus 2 is learning the calculus 1 and then we're applying those for calculus 2. So all of what we're doing for calculus 2 is application. So this is a question on application to integration, right? So when I did this just now, I'm getting -11/2 for my answer. Now, as a recap, I'm going to do the actual calculation. I'm going to do the actual calculation. Will we be required to do the actual calculation in the exam? No, because this is calculus 1. But I'm going to go back to what we would have done in calculus 1. In calculus 1, what we say is that we add 1 to the power and divide by the new power. So when we integrate in x squared, we're going to have x to the third over 3, see right here, so. And when we integrate -3, we're going to get -3x right here, so. Then we substitute the upper limit to lower limit. So it's the upper limit minus the lower limit. So it's going to be negative, it's going to be 2 raised to the third power over 3 minus 3 times 2 minus the lower limit now, which is going to be -1 to the third power over 3 minus 3 times -1. And then when we evaluate that, we can get 2 to the third power is 8. So we can get 8 over 3 minus 6. And then -1 cubed is going to be -1 over 3, +3. And we evaluate all of that 10/3, and then we get our answer to be -6 units squared. Right? But our answer, our estimation, was -5.5. or estimation was -5.5, but the actual calculation was indeed 6. So I am doing this to show you how close we are. Can you see how close we are to the actual calculation?
Yes, sir.
Yes, sir.
Yeah, man. And it is really not bad. Now, why is it that the estimation is important? Estimation is important because when there are some functions that are very difficult to integrate. There are some functions that are very difficult to integrate. We will not get a method necessarily to do that integration. However, we can approximate what the integral is going to be. And that is going to be as good as goal to get as close to the actual integration. So whatever we do, we have some leeways. Today I was working a question with some students. A very practical question. What they do, they gave you they gave the drawing of two figures joined together but separated by a line. And they are saying that one half is to be used as parking lot, and the other half is going to be used to build shops. And they're asking the students to go ahead and see how many shops can be built and the angles that are going to be used to strike out the parking lots. So let me ask you a question. Do you think so when the man them have one new development and they say, oh, housing seem to go up, and mathematics them using the man them have to know how much land them have, calculate the area of the plot of land, and can tell us, boy, you the plan, we can get 4 units, we can get 8 units, we can get 12 units out of this. Because if they don't calculate it, they are going to be building and recognize that they did not maximize. And as I speak about maximize, is one of the areas we're going to be using for the stationary points for this sorry, for one of our must-haves on the thing. So we're going to calculate stationary points of the multivariable function, right? So when we do the multivariable function, we are maximizing what it is that we have. If we don't maximize it, at the end of the day, sometimes we get one partner draw, and maybe this is a clear example. Sometimes we get one partner draw and say, yeah, say the partner run 300,000. You say, yeah, I have 300,000 in our pocket. And then you say, what, I have one bill for pay. The car want 2 tire. I want this, I want that. And you spend. And then at the end of the day, when they say, I need to buy one plane ticket, you recognize the money done. Because there are so many granular stuff that you had to deal with, and you don't see where the money go. It's the same thing the man them who are gonna build up them place, yeah? They're gonna say, but we never maximize the plot of land properly because I only get 10 units out of it. But if I'd maximized it properly, I could have gotten 15 units. And 15 units, it means that I'd have gotten 5 more units. Now think about it. If we could get 5 more units, if you actually maximize the plot of land, and each unit is being sold in a Kingston now, a unit have been a complex is being sold anywhere between $30,000 and $40,000, if not more, $40 million, sorry, for a property. So let us use the lower end, right? Say you can get 5 more units, and each unit is $30 million. $150 million you'd have been out of pocket for you, because you never calculate the thing properly. I don't know if you see where I'm going. Can you see that? Anybody, somebody?
Repeat, sir.
Not really, sir.
And I'm just saying, if you don't maximize your stuff properly, it means that instead of building 15 units, you'd have only built 10. But if you had maximized it properly, you could have built 15 units. And if each unit is being sold for $30 million, the extra 5 units that you could build is $150 million it will put in your pocket.
Yeah.
So it is important for us to maximize. Very important, all right? Now, this is where the time meets the road. What do I do now? This is where the time meets the road. Chevy, me not like how you like your behavior, you come to class, you don't have to be ill up teacher, and you're silent the whole time. Me not say nothing to you.
No,
Me
sir,
not
I
say
just
nothing.
reaching in, sir. What
Me
you
not, me
mean?
not, me not, me say. Me I cut you off. Me I cut you off, Shibby. The last
No,
time you come class, you come to class, you know, say nothing to me last time, innit? Me now watch you. It's all
yeah.
right, Papa.
Sir, I'm reaching late, man, so I just log in.
It's all right, Shibby. Me say it's all right. One love. One love. Big up yourself. Mikey reaching it? Mikey, you reach home already now? All right, him still a drive. All right.
Sir, you're calling?
Yeah, I'm asking for reach home now.
Yes, sir. Just circling.
Okay, cool. All right, now. So, where am I? All right, I'm gonna give you a question to try on your own for me. I'm gonna give you a question to try.
Could you
But what I'm
scroll
gonna do is
down, please?
say it again.
Could you scroll down for me, please?
No, man, what I'm gonna do. Oh my God, you sound awful.
Yeah.
Oh my Lord. Hush, hush. What I'm gonna do is I'm gonna send you. I'm gonna send you the example. Uh-oh. I'm gonna send you the example that. Oh, come on, no. I'm gonna send you the example that we just worked. All right. Mm. I'm gonna send you the example that we just worked. And in that example, towards the end of that example, rather, is a question to be done by you. Trapezoidal, Trapezoid. I've never taught calculus 2 and start at this point, but I'm trying to be creative. So I want you to work with me. This is normally like somewhere down there in the stuff. But I'm trying to mix up the stuff this time because I want to get these big boys out of the way. I want to get these big boys out of the way. Where am I? I'm looking at all right, so I'm sending you the document now. And I'm sending you the document now. All right, so look at the document. You can spend some time. It's in the WhatsApp. You can spend some time to go through the example on your own again. And at the end of that example is example 2 that I want you to do. I'm not in any rush. If that's the only other thing that we do for the rest of the class, that's fine. I'm not in another rush. So I'm going to mute. I am here. Take your time to just go through that calculation for me. All right? Start for me now. Thanks. Anybody here from Ottalie?
She just check text in the group.
She'll tell me she's not going to be late for no more class. You know. All right, one
She
work
says
here.
she's in traffic currently.
Oh, she's in traffic. All right, cool.
Sir, just a quick question.
Yes, Sean, go ahead.
Where we have where we write down the formula, right? The Vx is always going to be over 2.
Yes. No, the Vx is always going to be over 2. Yes. Yes, the Vx is going to always be over 2. Everybody understanding what it is that he's asking? What he's asking is if, are you seeing my screen?
Yes, sir.
Right. He's asking if this Vx here is going to be over 2. Yes, it's always going to be over 2. But remember, Vx is going to be, when you work out Vx in some questions, Vx may come out as a fraction. So you're going to have that fraction divided by 2. But as I go along, I'll point that out to you. It's just that Vx in this case was 1. So it's going to be 1 over 2. But Vx could be a half. Sometimes in the work out, Vx could be a half. So if Vx was a half, what fraction will this be? So 1/4. So 1/4.
1/4.
Right? Yeah, man. So so it's going to always be over 2, but you have to be careful because sometimes the value of Vx, the change in the value of x, that's what it is. The change in the value of x can be a fraction. The first example we did, it was a whole number, but the change in the value of x can be fractional. But as we go through those questions, we will see how we can come across and circumvent those things. All right, so start working again, please. If you have any other questions, you can let me know.
Sir, quick question. When
Yeah, when?
oh sorry, I was muted. When n equals to 3, right? That determines the amount of count that we times it by in the formula below, right?
Say it again. When n equals 3, it equals what?
Hmm?
Say it again. Start the question again.
So when n equals to 3, that determines the amount of function we will have, right? So in the example, you have it going up to x to the
No. Well, n equals 3
Equals
tells
3.
us how many ordinals you will have. And remember, it is the number of ordinals that we're going to be substituting into the function in order to get out our calculation. So n equals 3 tells us that we have 3 trapezoids, but those 3 trapezoids will give us 4 ordinals. And it is the 4 ordinals that we're going to be using in order to do the substitution. So I'm going to start with my lower limit first, then add consecutively the width of the trapezoid until I reach the upper limit. Make sense? I don't know if I answered your question.
Okay.
Well, hold on, sir. Repeat that again, sir. Now you catch up on it.
All right. So in the question that we have, the change in x, which is v of x, is going to be the upper limit minus the lower limit divided by 2.
Yeah.
So it's going to be 2 minus 1, which is 2 plus 1, which is 3. And the number of trapezoids I have is 3. So 3 divided by 3 is 1. Now, that 1 is going to be divided by 2. Because remember the question that Shamari asked, if you always have that 2 in the formula, the change in x, v of x, the change in x, that is, it's always going to be over 2 for the trapezoidal. There are other approximations that is going to change from 2 to 3, but we are only required to learn the trapezoidal for calculus 2. All right? Now, what is going to happen is I am going to be calculating my change in x. My change in x is going to tell me the width of the trapezoid. It's going to tell me how wide the trapezoid is. So in this here case, my trapezoid is supposed to be 1 unit apart. So if my lower limit is at -1, I'm going to first write my lower limit because how do I know the starting point? My starting point is going to be my lower limit. How do I know my end point? My end point is going to be my upper limit. So if I start with -1 and go all the way up to 2, -1 is going to be my starting point. When I add the width of the starting point, -1 plus 1 is going to give me 0. Can you check the paper there to say that 0 is the next ordinal on the paper? You see that? I'm going to add 1 to 0, I get what? I get 1, don't?
Yeah, then get 2.
Yeah, man, I'm going to add 1 to when I add 1 to 1, I get 2. The question is, okay, but I don't add 1 to 2 to get 3. And the answer to that question was, because the upper limit ends at 2, there is no need for me to go and do any further because I would already reach the other end point. You follow me?
Okay.
Yeah, man. So let's continue. How many trapezoids this one has? 6?
7, I think.
No, how many trapezoid the question says?
6.
6.
6. All right. So how many ordinals we have?
7.
7. All right.
7. Right. What did you get for the width of the trapezoid?
Half.
So what's the lower limit?
-1.
-1.
All right.
-1.
So the first starting point going to be what number?
-1, sir.
-1.
Excellent. And then the next ordinal going to be what?
-1/2.
-1/2.
Very good. Very good, because you're adding a half to -1. So you're going to get -1/2. What is the next ordinal?
0, sir.
0. And what is the next one?
1/2.
Half.
And then what's the next one?
1.
Yeah, that's where I
And
stopped.
then what's the next one? No, but tell me, it is 1.5. And what the next one?
2.
Easy 1, 2, 3.
Oh, you parrot that.
Easy 1, 2. Hello, I will even mark to carry. Me to tell you. And that's my plan for this time around. I'm getting the big boys out of the way because we're going to learn it early. So we're going to practice it. And we're going to the exam, going to mash it up. All right? So yeah, man, that is it. Continue working. Those are correct. Continue working for me. I'm right here.
We can't use like 0.5.
My general rule is to use fractions because if you get 1/3, I don't want to use 0.3. 0.5 is a terminating decimal, so you're going to use all the values. But if you get 1/3 and you get 0.33333, I only decide say I'm going to use 2 decimal places, your answer, remember, no, it's an approximation we're getting for the answer now. So we can round off within an approximation because a round off within the approximation, we are approximating the approximation. I don't know if it makes sense right there. You get me?
Kind of. You
Yeah,
said
man.
to get the ordinals, we add the width of the
Yes.
trapezoid to the
Yes.
starting point.
Yes.
And then each time we add one, that will add what the width is to.
Yes. Until we reach the upper limit. Yeah, man. I see me so. All right. I'm going to stop. Quick and fast. I want you to hear how far you can get to the question. So please start working. Look back. If you have to look back at what it is that we did for the first example, I have no problem. I am not necessarily saying that we have to finish this topic today, but I want you to even get a question on your own into the stuff. So I can give you one for homework. Oh, it's not going to homework. I want you to do the homework here. I won't give you 100 questions to do. I may give you 2 or 3 questions. Do the homework until we meet again for next class. God's willing. All right. All right. Continue working, please.
Sir, I'm not sure what to do after the substitution. In the function where you have f of x to the 0, right?
To the 0, no problem. So have you calculated all the ordinals?
I have
Tell me the ordinals, please.
-1 half
Mhm. -1 and the second one is?
half
No, ma'am.
minus a half,
Yes, ma'am.
then 0,
Mm-hmm.
then half,
Mm-hmm.
then 1,
Mm-hmm.
1.5, and 2.
Mm-hmm. All of those now must be substituted into the function.
That's not what I'm talking, is the next step that comes after
What,
that.
what,
We plug
what
it
is the
in
next step that comes?
integration,
What is the next step that comes?
where we plug everything into the integration back into the question with the v over x. V of x over 2. The bracket functions are, that's where I
All right, hold on. So you have the ordinals. Did you substitute the ordinals into the original function?
I did.
And you got an answer out, right?
Yeah.
And you did you write the first term and then the other terms multiplied by 2 and then the last term is multiplied by 1. It remains as it. They did all of that?
Yeah. Or I think so.
Right. And then we have x over 2. You're changing x over 2.
I'm not hearing you.
You're changing x over 2.
Terminate area.
What is hearing me?
You gone very far.
Right there. Now move.
Huh?
I'm right here. I'm not moving at all.
I'm not sure if it's something in your mic. Go again.
Are you hearing me now?
Much better.
All right. So I'm saying you're changing x divided by 2. What was it? What was it? Sorry. What did you get for v of x? What value you got for v of x?
Quarter.
Quarter. Oh, man.
Huh?
V of x is a half, right?
Yeah.
So v of x over 2, you can get a quarter.
Yeah.
Right. So you're going to multiply everything by a quarter, right?
Mm-hmm.
Good. So when you would have done that, you're gonna. So when you have done that, you're gonna have a quarter times continue now. A quarter times what?
That's where I'm stuck.
No, man, it's going to be a quarter times all of the values. That's what I was saying to you. All your values now you're going to multiply it into the function.
So it will be the first function, the second, and so on and
Yes,
so
ma'am.
forth.
Yes,
Okay.
ma'am. Yes,
Right.
ma'am. Cool. All right, and I say too long now. Well, nothing sugar in it. Oh. Talk to me now, somebody, please.
Opinion.
Where you ask, sir?
I finished your question already.
Yes, sir.
Nice. All right, so let me. All right, so so question 2. Remember now, it is not going to be divided by 3 as it did the last time. The last time we divided it by 3 because our number of trapezoids was 3. In this here case, we have 6 trapezoids. The value of n is equal to 6. N is referencing the number of trapezoids. All right, so we divided it by 6 here. Now, the upper limit is 2, the lower limit is -1. So it's going to be the upper limit minus the lower limit. So it's 2 minus -1. And that is going to be 3/6. And 3/6 is a half. So that is just the value of V, the change in X. Vx, the change in X, is going to be a half. That 1/2 is going to be divided by 2 to give me a quarter, which is going to be that scale factor. Let me show you the scale factor. I'm talking about this scale factor. This scale factor, that's why I get this 1/4. All right. So when we got a half, it is telling me then that the width of my trapezoid is 1/2. The width of my trapezoid is 1/2. So I'm starting with my lower limit, which is going to be -1. And it's a positive 1/2. So -1 plus a half is going to be -1/2. That's why I got this one. And -1/2 plus a half is going to give me 0. That's why I got the 0. And 0 plus a half is going to give me a half. That's why I got the half. And a half plus a half is going to be 1. That's why I got the 1. And 1 plus a half is 1.5, which is the same thing as 3/2. And 3/2, which is 1.5 plus a half is 2. So if you look at it, I'm at my lower limit and I'm up to my upper limit. I cannot pass my upper limit and I cannot go below my lower limit. All right. Now that I have my ordinals, I now must substitute these ordinals into my function. What is my function? My function is x cubed minus 3. See here, recall, my f of x is x cubed minus 3. So I'm substituting my ordinals. Start with -1. -1 squares is +1 minus 3 is -2. We're going to go to -1/2. -1/2 squares is going to be 1/4. 1/4 minus 3 is going to be -2/4, -2 1/4. I'm taking out a quarter, -2 3/4. Your calculators are going to be very important right here. And if I were in a face-to-face class, I would show you the calculator that I prefer you guys having. Not a join us, but it's one where preferably if you have like a natural display calculator. What is a natural display calculator? A natural display calculator, you're able to put your function into the calculator just as this. You can put 1 divided by 2, just like how you write it naturally. That's why it's called a natural display. So for those of you who need to upgrade your calculator from a join us, I'm just saying, please go purchase you a natural display calculator. There are many of them on the market. My preference is really like Casio, but purchase one that is within budget, but preferably something with a natural display. All right. So, I'm substituting my next one, my 0. All right. So you have to be careful. So what I did was to do this one, then I jumped to 0, then I jumped to a half, then I jumped to 1, then I jumped to 3.5, and then I do that. You have to be careful to know which is your first one and which is your last one, because you don't want to multiply mistakenly the first one by 2, and the other one who was supposed to be multiplied by 2, you don't multiply that by 2. So you have to be very careful that you know which is the first and which is your last. So I'm substituting all of the values in here. You're supposed to know how to do the substitution. Question. Did you all get these answers when you substituted?
Yes, sir.
Good.
Sir.
Chevy, who is
Yeah,
good,
man.
good. Nike, who is the?
No, sir, I'm not get all of them.
All right.
Yes, sir.
Shabari.
Wait.
Uh-huh.
Hold on. I have a
Alright.
positive 2 and 3/4.
Is it 2 and
Yes,
3/4? Yeah, issues.
For the positive half.
Yeah, man, it's going to be the same thing. Remember when you have negative a half square, it's going to give you the same answer as positive a half square. So these two answers are going to be the same.
Sir, quick question. What if you did write negative 11/4?
Same difference.
Okay.
Oh, that means you're right, then, sir.
Yeah, but
Yeah, man.
sir, which one is the last one?
The 2. My upper limit 2. So my last one is going to be 1. This is my last one, and this is my first one.
Okay, I did that one wrong. All right.
Simon, what is the?
Yes, sir, got them.
Good. Shabari, you got them too, right?
Yes, sir, I got them.
Very nice. Now, let me just pause and say something to you guys here. You must try and understand everything that we do in our online class before you leave class, because you're all going to be asking, you're all going to be saying to me, sir, I'm going to be watching the video, I'm going to do some work. But when you check the stuff, family life, professional life, social life, coming to the play, and we find yourself after class on Monday, God's willing, and no work no get done. Always try to understand. So if you're not following something in class, please, yours is a responsibility. Say, sir, help me out. I'll be more than willing to do that. All right. So yes, so what we're going to be doing now, remember, at this point in time, you must be able to identify your lower limit, because that one is not going to be multiplied by 2. And you must also be able to identify your upper limit, because that 2 is not going to be multiplied by 2. Please, I beg of you. I beg of you. So my 1/4, remember how we got the 1/4? It's a change in x divided by 2. The change in x was a half, and a half divided by 2 is 1/4. So watch me. My first one is -2. I write it back as it is. My second one is -2/3. So I'm going to have my 2 times -2/3. Then -2 times 3, -2 times -2 3/4. -2 times -2, 2 times -3/4. This is my last one. It's just going to be as it is. This is pure straight calculator work. You substitute all of that, I'm going to end up with this value. Then I'm going to have -23.5. And when I multiply that by 1/4, I'm going to get -5 7/8. Anybody got that for the answer?
Yes, sir.
Good job.
Yes, sir, but I didn't put it in mixed fractions.
Okay, you have 47, -47/8.
Yes, sir.
Good job. Adrian, Chevy.
Yes, same, sir. -5 and 7/8 units.
Very nice.
Sir, technically,
Shashi.
I'm here to know. It's just that I messed up the last ordinal. So once
Okay.
I fixed it, then I got it. Yes, sir.
Nice. Good job. All right. And that's it. That's it for today. That's it. I'm going to be sending you 2 questions to do between now and the weekend. The topic is finishing now. We start this week and I finish the topic already. Topic done. There's nothing more to the trapezoidal. There's nothing that I'm hiding from you. It can't come any other way but this way. You're not, what you're doing is an alternative method to integrate. The difficult part of the question is the top part to know if you are given the number of trapezoids or the number of ordinals. If you're given a number of ordinals, you'll have to subtract 1 from that to know the number of trapezoids, because you have to divide up here by trapezoids, the number of trapezoids. So if they say to you that it has 6 trapezoids, you know you may have 5 ordinals. If you have 6 trapezoids, you have 7 ordinals. If the question said to you that it has 10 ordinals, you know that the number of trapezoids is going to be 9. So you have to divide this by 9. So you have to know the difference between trapezoids and ordinals. That's why I went through that exercise with you with your hand, so at least you can always remember that. Let me find out from if you have any questions of me. Any questions?
So, sir, when finding the ordinance, if given the trapezoid, the formula would still be the same.
Same formula, no? Same formula. The only thing is, all right, so and the truth element is, I didn't even do any other question. I don't even have another question to give you. Let me just show you what I'm going to give you for homework. So this is a past paper. This is a May 2019 past paper. Oh, you only need to start procuring your past papers here. You see what I'm reach already? I reached past paper questions already to show you how not difficult this is. It
So
gives you a sketch below. Go ahead.
Yeah, we
so
don't know.
you're gonna add homework to this and then send it to us?
Yeah. I'm gonna add a homework and then send stuff to you.
Okay, sir.
So this is a May 2019 paper, and then it gives you the information. This is a 20-mark question. Your exam questions now are 30 marks each. So you get a question like this for 20 marks. Then just find another full 10-mark question to put on that. If you can get the full 20 marks, so that you're good to go. You must pass the exam. You must pass the exam. You may say to me, sir, you make it sound easy. It's not a matter of me making it sound easy. I'm telling you what it is. Right? So I'm not going to even give me any more information. I've done this question already. I'm not going to even give me any more information. You are going to read the question. Remember, we're talking about plot of land, and I always give you these examples when I'm talking about integration. You will see the integration in this write-up, and then you can go ahead and do it. All right, I'm going to pause. Thanks for coming out. We will have conversations come next class. Please ensure that you work, and you work. Have a good one.
Sir, before you go, can you quickly go back to the question that we're just doing? Yes, let me see. I want to see the answer. Just want to make sure. Okay. All right. Thanks, sir.
Bless up. Have a good one, guys.
You too, sir.
Mhm.